By the way, these quick reviews at the end of the chapters, those are really good too. If you never noticed those, they're just kind of summaries. All right, so let's see. Number 1. So these are true, false. Mark the following statements as true or false. We can go through some of these kind of fast. A loop is a control structure that causes certain statements to execute over and over. That's true. Right? True, yeah. B, in a counter-controlled while loop, it is not necessary to initialize the loop control variable. That's false, right? You got to do that. Otherwise, you might not go inside the loop at all, right? C, it is possible that the body of a while loop may not execute at all. That's true. We just talked about that. D, in an infinite while loop, the while expression, the decision maker, is initially false, but after the first iteration is always true. That's false. That's not how it works, right? You have that update part that updates it. All right, so part E, let's see, the while loop, j is equal to 0, while j is less than or equal to 10, j++, terminates if j is greater than 10. True, right? Yeah, that's what it does. Good. Part F, a sentinel-controlled while loop is an event-controlled while loop whose termination depends on a special value. True. That's what it does, right? That's the sentinel value. G. To read data from a file of unspecified length, an EOF or end of file controlled loop is a good choice. True, right? Yeah. Cool. Good deal. How about H? H says, when a while loop terminates, the control first goes back to the statement just before the while statement, then the control goes to the statement immediately following the while loop. That's false, right? It doesn't go back. It just, when it terminates, it just goes to the next statement afterwards. You have a couple more in your book, in your 8th edition, don't you? You have an I and J. Let's see, I says a do while loop is called a pretest loop. That's false, right? A do while loop is a post-test loop, so that one's false. J says after, let's see, executing a break statement in the body of a loop immediately terminates the loop. That's true. That's true. That's what it does. All right, good. All right, how about, that one's different. So there are some differences here. Let me kind of look around, look through some of these. Some of these, what is the output of? So there are some differences between the 7th and 8th editions. Let's see. What does number 5 do? This one is, I think it's, yeah, number 5 in the 8th edition as well. I think this one's probably easy. When does the following while loop terminate? CH is equal to D, while A is less than or equal to CH, and CH is less than or equal to Z. So what is that doing inside of there? CH is equal to static cast char, static cast int, CH plus 1. That looks kind of like there's a lot going on there, but all that's doing is converting CH into an integer, adding 1 to the ASCII value, and converting it back to a character, and assigning it back to CH. So it's just incrementing CH and making it go down to the next character, right? So it starts off at D, a capital D. So as long as it's in between capital A and capital Z, it's going to increment. So the question is, when does it terminate? It terminates when CH is when it's greater than capital Z. It also terminates if it happens to be less than capital A, right? But the way that they've written it, it's going to go up. So it'll terminate when it gets to be greater than capital Z. No, okay, that one's kind of silly. So these are a little bit different, but since let's go ahead and do the ones that are here. These are different than a little bit different than the ones in your book, but let's go ahead and look at them real quick. Actually, I kind of skipped those. I'm sorry, I'm indecisive here. How about number 9? Let's just see what that one does. Suppose that the input is, and so this one's a little bit different than the one that you have in the book, in the 8th edition. But let's go ahead and do the one up here. Suppose that that's the input. What's the output of this code, right? So what I would do is, and it may or may not be necessary here. Let's see. Again, I'd like to keep a list of my variables and update things as they go, as we go through. Let me find Notepad here. So I'll just kind of keep track of things with Notepad. So on this one, this is number, you can just mark it as number 9. So we've got a num, and we've got a sum, and we've got our output. So num starts off at, well, sum starts off at 0, right? And then they're saying, hey, suppose that the user types these numbers in. So there it says cn num, that's going to be 10 initially. And so it's going to test, is 10 not equal to 0? That's true. So it's going to go inside the while loop. And if num is greater than 0, 10 is greater than 0, sum is equal to itself, 0 plus 10. Okay. And then we won't do the else, it'll get the next number. So now num will be -6. And then it's going to test again. -6 is not equal to 0, so we go inside the loop. And if -6 is greater than 0, is that true or false? That's false, right? So it's going to the else part, right? So sum is equal to 10 minus -6. 10 minus -6 is what? 16. So it becomes 16. All right, then we get the next. We haven't even outputted. There's only one thing that gets output at the very end, right? The next value of num is 12. 12 is not equal to 0. So if 12 is greater than 0, that's true. So we hit the if. So 16 plus 12 is what? 28. All right, and then get the next value for num, which is -5. -5 is not equal to 0, so go inside the loop. If -5 is greater than 0, well, that's false, so we go to the else. Sum is equal to 28 minus -5, which is what? 33? And then the next value of num is -4. Same thing, -4 is not equal to 0, so go inside the loop. If -4 is greater than 0, that's false, so it goes to the else. Sum is equal to 33 minus -4, which is what? 37. Get the next value of num, they say is 0. And then 0 is not equal to 0. That's false. So it exits out of the loop. And so our output is what? Sum equal 37, like that. Does that make sense? So that's how you would do that. You would tracing through the code like that. Now, if you try to keep track of all that in your head without writing it down, you're more likely to make a mistake, right? That's quite a bit to keep track. And so that's why on questions like these looping questions, I think it's a really good idea to make notes as you trace through the code like that. All right, questions? Make sense? All right, so let's see what's next. I think this one might be the same. Actually, it's a little bit different than in the 8th edition, but it's pretty much the same question. So number 10 says, correct the following codes so that it reads and finds the sum of 20 numbers. So how do you fix that? Because there's some issues with it right now. Well, the first thing I see right off the bat is the semicolon, right? So on your while loop, so you need to get rid of that semicolon because that's going to mess things up. So get rid of that. Also, yeah, in the 8th edition, this cn num is down here, right? So I think that's where you want it. Oh no. No, because they're getting the first value before the loop. So there are a couple differences between the 7th and 8th editions on this one. So if you have it there, if you get the first value before the loop, then this will need to be at the end. You want to get the next value towards the end, I believe. Or you could just get rid of this one altogether and leave it where it is right there. I think that would work. Let me retype it. So what is this going to do the way that they have it right here? It's going to get the first number before the loop starts. And suppose the semicolon is not on there, okay, after the while loop. So it's going to get the first number, and then it's going to get the second number before it ever adds the first number to the sum, right? The way that they've written it. And then they're going to update the counter. And then, what? Sum is equal to sum plus count. They're wanting the sum of the numbers, right? Not of count. So instead of sum plus count, you want sum plus num. So there's several things wrong with this one. So what would that look like? How would you write that? Let's just rewrite it. So I would say, how they started it is fine. You don't even need to do that cn num before the loop. That's not your initialization. Count is controlling the loop. And you've got count is equal to 0 up there. That's fine. Right? So I would just leave that one off and just say while count is less than or equal to 20, what do you want to do? First thing I would do is get the num. Second thing I would do, I'd go ahead and add the num to the sum. I'd say sum is equal to sum plus num. And then I would update my count. Count plus plus, like that. Would that do it? Actually, there's one more problem with that. How many times is that going to go through? That's going to go through 21 times, right? When count is 0 through 20, because they have less than or equal to 20. So, and they only want it to go through 20 times, I believe. So you could either start count off at 1 or just do it less than 20. That would take care of that. Yeah, I think that would fix that. So count goes through from 0, and when it's 20, it's false. The loop is false, and it exits out. And each time it's going to get a number, add it to the sum, and then increment the counter. Does that make sense? All right, so that's that. Let's see what else we've got here. Some of these. Let's see number 18. I had that one marked. So at number 18, what type of loop, such as counter control, sentinel controlled, or whatever, will you use in each of the following situations? So this one is also number 18 in your 8th edition. A says the sum of the following series, 1 plus 2 divided by 1 plus 3 divided by 2 plus 4 divided by 3, and so forth. So what is that doing? That's it's going up, right? It's kind of, you could do that with some kind of counter, right? Starting at 1 and going up. So I would probably say some kind of counter controlled loop on that one. Spell controlled correctly. B, sum the following numbers except for the last number. So you've got so what's up with that last number? How is it different than the others? It's a negative number, right? A -1. So something like a sentinel controlled loop would probably be good for that. You could say, like, enter a number or -1 to quit, right? Or you could use a flag controlled loop for that as well. But I would probably say sentinel. Either sentinel or flag controlled loop. And C, a file contains an employee's salary. Update the employee's salary. Probably some kind of end of file loop, right? Cool. So that one's easy. How about 23? I think this is the same one as your 23. So let's do these. So these should be pretty easy compared to the nested ones. So 23 says, state what output, if any, results from each of the following statements. So A, and so what I would do on here, I mean, if you need to, we can keep a list of our variables if necessary. We may or may not need to, right? So look at A. So A says for I is equal to 1, I is less than or equal to 1, I plus plus. And then every time inside of the loop, it's going to output an asterisk. So how many times is that loop going to go through? Just once, right? So I will be 1. 1 is less than or equal to 1 is true, but then when it becomes 2, it's false, right? So that one, we don't need to take any notes on that one. There's your output right there. So it's going to output 1 asterisk, right? Cool, easy enough. How about B? For I is equal to 2, so look at the loop and see what it's doing. I starts off at 2, it goes up by 1 every time because it has I plus plus. And then the test is I is greater than or equal to 1. So what do you think on that one? Yeah, so that's going to be an infinite loop, right? So the first time, just start it. I is equal to 2, right? 2 is greater than or equal to 1. Yes, so we're going to output an asterisk. And then I becomes 3. 3 is greater than or equal to 1. So it's going to go through. Then it becomes 4, 5, 6, 7. It never ends, right? It's never going to be great. You're never going to get it to where it's less than 1, right? So you got an infinite loop. However you want to write that. How about C? Yeah, is that the same thing? So so notice I starts off at 1, but it's going down by 1 every time, right? We have I minus minus. So the values of I are going to be 1, 0, -1, -2, -3, and so forth. And the test is, well, I is less than or equal to 1. So it's just going to keep going on forever as well. So it's the same thing, infinite loop, right? Good. How about D? Let's see. Yes. Good. So let's see. I starts off at 12. It's going down by 1 every time, right? And the test is while I is greater than or equal to 9. So just kind of think about the values of I. I is 12. 12 is greater than or equal to I. So output's an asterisk. Then I becomes 11. It's still true. I becomes 10. 10 is greater than or equal to 9, yes. Then it becomes 9. 9 is greater than or equal to 9. It's equal. Then I becomes 8. And the test is false, right? Cool. So you get 4 asterisks on that. How about E? What's that one doing? Get 6 asterisks. So I starts off at 0 and it goes up by 1 every time. And every time you get an asterisk. So there's I is equal to 0, 1, 2, 3, 4, 5, and then when I becomes 6, it's false. So how many? That's 6 asterisks, right? So it goes through 6 times. And F. Oh, okay, so this one's a little bit different, right? So notice on F, you've got the update part, right? I plus plus. But then, just to mess with things, they've got another statement in there that says I is equal to I plus 1 inside of there. So it's going to do that, and it's also going to do the update part, right? It doesn't like take the place of it or anything. So just kind of trace through there. I is equal to 1. 1 is less than or equal to 5, right? So you output an asterisk. And then the next statement, I is equal to I plus 1. I becomes 2. But then it does the update part, I plus plus. So I becomes 3. and then it tests it. 3 is still less than 5, so it goes inside the loop, outputs an asterisk. I was 3, I'm keeping track of it in my head. The next statement, I is equal to I plus 1, increments it to 4, and then the update increments it to 5, right? And 5 is still equal to 5, so you go through one more time. I becomes 6, and then it becomes 7, and the test is false. So you get 3 asterisks. Does that make sense? Cool. Good. So that's number 23. We didn't need to do that. How about How about 24? Write a for statement to add all the multiples of 3 between 1 and 100. So how would you write that? A for loop. All the multiples of 3 between 1 and 100. Right? So you need some kind of counter. So whatever you want to name it. You want to go with, let's go with x. For x is equal to 1. They're telling us it starts at 1. Sorry. And then between 1 and 100. So x is less than or equal to 100 if you're including 100. And then what's the update part? Well, we can write this different ways, but if we're starting at 1, let's just make it go up by 1 every time. But we don't want to output all the numbers, right? Just the multiples of 3. So how do you test if it's divisible by 3? If x mod 3 is equal to 0, then it's divisible by 3, right? And if that's true, what do we want to do? Output it? No, add. Sorry. You want to add all the multiples of 3. So we need some kind of sum in there. Sum is equal to sum plus x. And we didn't declare sum or initialize it, so we need to do that up here someplace. Sum is equal to 0. If x mod 3 is equal to 0, then add that number to the sum. Yeah. What do you think? And then if you wanted to output that, you could output it. Sum equal. Something like that. So it's just a counter control loop that goes through 100 times, 1 through 100, and we test. If that counter is divisible by 3, add it to the sum. But if it's not, don't do anything. You'll just go to the next time through the loop. So there's your 24. How about this one? I haven't done this one yet. I may regret it. Number 32. Number 32, I think it's the same as the 8th edition. How many times will each of the following loops execute? What is the output in each case? All right. So some of these are do while loops and some of them are while loops. That's why I wanted to look at this one. So how about the first one? X is equal to 5, y is equal to 50, and then we've got a do while loop, so it goes through. So let's just kind of trace through this a little bit. So we have an X, starts off at 5, Y starts off at 50. Here's our output. So it goes inside the do while loop, right? It doesn't test first. So X is equal to X plus 10. So it adds 10 to X, right? So X becomes 15. And then it tests. If X is less than Y, 15 is less than 50. That's true. So it goes back and repeats it. And then what? Adds 10 more to X. So X becomes 25. Then test it again. 25 is less than 50. So we go back and repeat it. So it's just adding 10 to it every time, right? 35 is still less than 50. So it's 45. 45 is less than 50, so it goes back and repeats it. Oh, sorry, 55. And then it tests it. 55 is less than 50 is false. So our output is X space, no, sorry. It's the actual value of X, right? 55 space 50. So how many times was that? 1, 2, 3, 4, 5, 6 times. Wait a minute. Or was it 5? Because it did it. So when it was, that's why these things are tricky. So when it was 5, when it was 15, 25, when it was 35, it became 45. Is it 5 or 6? The book says 5. What do you think? But when it's 55, when it goes back and repeats it when it's 45, so 45 is less than 50, so it goes back and adds 10 to it, and X ends up being 55, and then the test is false. So X does end up being 55, but how many times is that it went through? So when X is 5, it did it. When X was 15, it did it. No, but it doesn't go back and repeat it that last time, right? So it is only 5 times. When it exits, when it becomes 55. So that was only 5 times. That's a little tricky. Does that make sense? You almost need to make a mark or something when it executes. All right. How about B? Ugh. Aren't these fun? So what does B do? I need to keep track of my time. We might not do all of these on this one. Let's see. Or unless we can go through them fast. X starts off at 5. Y is 80. I'm sorry, got the wrong thing. Gosh. It's easier when I write it on paper. Or on the, I usually would write it on the whiteboard. All right, so what is B doing? So it's a do while loop. X is equal to X times 2. So it's multiplying times 2. The test is the same, right? X is less than 5. So it's going to, but only outputs afterwards. So it's 5 and then 10, right? And then 20. And then 40. And then 80. Test is while it's less than. So the output will be 80, 80, right? Is that 4 times? Yeah. All right. All right. I'm getting bored with this one. Are there any other? I think you guys can handle that. But let's do, maybe look at one of the while ones. See how that compares. How about D? On D, you've got X and Y in the output. X starts at 5. So D is just a regular while loop. So 5 is less than, what is Y? 35. So that's true. So it adds 10 to it every time. So 15 is less than 35. And 25 is less than 35. 35 is not less than 35. So it exits out. So your output is on D 35 and 35. How many times is that? 3 times, I think, is what I counted. Yeah. I was kind of hoping they would have one that didn't go through at all. I don't think they do. All right, that's enough of that one. I don't want to spend all the time doing that one. We're going to come back to 42 because we were working on that one before, but we didn't quite finish it. Yeah, remember that one? How about how about 44 and 45? I think those are the same. So number 44, what's the output of the following code? Notice in there you've got a break statement, right? So what's that going to output? So let's keep track of our variable num. Here's our output. So num starts off at 12, okay, and then test. While 12 is greater than or equal to 0, okay, that's true. So go inside of there, and then we have this if statement. If num mod 5 is equal to 0, break. 12 mod 5 is 2, right? So that's false. So we go on to the next statement and output num, which is 12 at this point, and then a space. And then it says num is equal to num minus 2. So num becomes 10, right? And then it goes back and test. While 10 is greater than or equal to 0, that's true. So it goes inside the loop. If 10 mod 5 is equal to 0, 10 mod 5 is 0. So that's true. So what do? We break out of the loop. So it totally breaks out of the loop, and we're done with the loop. And that's it. 12. Did everybody see what's going on there? So as soon as you encounter the break statement, it breaks out of the loop altogether. How about number 45? It's the same type of thing. We have a num. Here's our output. But this time it's a continue statement. Also notice there it has num plus plus inside of here. So on 45, they start num out at 12. And they say if num, first of all, test, 12 is greater than or equal to 0, right? If 12 mod 5 is equal to 0, well, that's false, right? 12 mod 5 is 2, so it's not going to do that. So it's going to go to the next statement afterwards, which says cout num and a space, 12 space. And then num is equal to num minus 2. So just like before, num goes down to 10. Sorry. Wrong spot. 10. And then we go back and test. 10 is greater than or equal to 0 is true. And then we hit the if statement. If 10 mod 5 is equal to 0, 10 mod 5 is 0. So that's equal to 0. That's true. So it says num plus plus. So what are we doing? We're adding 1 to num, right? So num goes up to 11. It was 10. And then continue. So what happens with the continue statement? When it hits the continue statement, it doesn't finish the loop. It goes back to the beginning of the loop to test it. That's how the continue works. Usually I've seen break and continue questions. I usually see them with for loops. If it's a for loop, the continue is going to go and hit the update part. It'll do the whatever's in the update. So here they had to make sure they had their update inside the while loop. So anyway, it goes back and it tests it. 11 is greater than or equal to 0. True. So go inside of here and then test it. 11 mod 5 is 1, so that's false. So it'll go through and output 11 in a space. And then subtract 2 from 11, so you get 9. Then test it. 9 is greater than 0, true. And so the if statement, if 9 mod 5 is equal to 0, that's 9 mod 5 is what? 4. So that's false. So it comes down here and outputs 9 and a space. And then subtracts 2 from 9. All right, so 7. Let me know if I mess up anywhere. 7 is greater than 0. True. So if 7 mod 5 is equal to 0, 7 mod 5 is 2. So that's false. So it goes down to the next part and outputs 7 and a space. Subtracts 2 from 7. So you get 5. 5 is greater than 0. That's your test part. That's true. So it goes in. 5 mod 5 is 0, right? And so this is true. So what does it do? It adds 1 to 5, so you get 6. And then continue will make it skip to the beginning of the loop, so it doesn't finish the loop. So 6 is greater than 0, that's true. 6 mod 5 is 1, so that's false. So we don't do the if, so it'll output 6 in a space, and subtracts 2 from 6. And so you get 4. 4 is greater than 5, yes. 4 mod 5 is 4, so you don't do that, but you output 4 in a space. Subtract 2. 2 is greater than 0. 2 mod 5 is 2. So that's false. So you go into the next thing, 2 in a space. Then subtract 2. All right, so num is now 0. 0 is greater than or equal to 0. Yes, it's equal to 0. So we do this thing again. 0 mod 5 is 0, right? 0 mod 5, whenever you 0 mod anything is 0, right? So that is true. So we add 1 to num. So num is now 1. And then we continue. And so it goes back to the beginning. So we do this again. Just when you thought you were done, you're not. 1 is greater than or equal to 0 is true. So you go inside of there. 1 mod 5 is 1. So that's false. So you output 1. And it subtracts 2 from it. So num is now -1. And then you test, while -1 is greater than or equal to 0. That's false. So it exits out and technically goes down the next line. So there you go. Does that make sense? So that one wasn't as quick and easy as the break one, right? That was 45. Yep. Cool. So hopefully that illustrated a little bit about how break and continue work. All right. Let's go back and let's finish this number 42. We didn't finish that one last time. Remember this one? Nested for loops. I'm trying to remember which ones that we did. I think we did A. Did we do B?
A, B, and D.
A, B, and D?
Hold on, no, that was 32. You said which number?
42? We were working on it last time. Actually, I still have my file here. Yeah, so last time we did A, B, and D. So here was, remember this? We did this last Thursday. Nested for loops, a loop inside of a loop. So A printed this. B printed this upside down triangle thing. We skipped to D. D did this, had basically just counted up. And I even had the code for all this, I believe. Right, so this was D we had done. Remember that? So let's go back and look at C real quick. Is this it? Oh yeah. In fact, we've almost kind of looked at this in one of the examples, I believe. C looks like that, I think. So yeah, right here. So I would do it the same way. I'd keep track of my variables. So you've got an I and your J and your output. So C says I is equal to 1, I is less than or equal to 5, I plus plus. So unless there's something inside of the loop that messes with the value of I, the values of I are going to be 1, 2, 3, 4, 5, right? And just like before with these others, the only indel that we have is after the inner loop and before the outer loop ends. So we're going to end up with 5 different lines of something. Okay. So the question is, what's inside the inner loop? So again, the values of I are going to go, 1, 2, 3, 4, 5, and stuff like that. So the first time through the outer loop, what's J doing? So J says it says J is equal to 1 and it's going up by 1, J plus plus. But the test is J is less than or equal to I. And every time it's going to output J in a field width of 3. So this first time through the outer loop, J is 1, I is 1. So it's going to output in a field width of 3, J. And then J becomes 2. And then the test is 2 is less than or equal to 1. That's false, right? 2 is less than. So this first time through the outer loop, the inner loop only goes through 1 time. And then I will become, and then you go down the next line, and then I will become 2. 2 is still less than or equal to 5. So J is going to start back over at 1. And this time, it's going to output 1 and then a 2, right? Actually, it's not like that. Because the value of J will be 1. 1 is less than or equal to 2. And then it becomes 2. 2 is less than or equal to 2. Right? And then it becomes 3. 3 is less than or equal to 2 is false. So it exits out. So every time we go through this outer loop, the inner loop goes through one more time than it did previously. On the third time through the outer loop, the values of J will be 1, 2, and 3, right? And then it's false when it becomes 4. So you're getting this triangle thing. I'm sorry, 3, like that. So how many times do you do that? Sorry, when I is 4, again, the values of J will be 1, 2, 3, and 4. Then when I is 5, 5 is still equal to 5. So you get this 1, 2, 3, 4, 5. And then when I becomes 6, the outer loop is false. So there's your output on C. So we can test that. So there you go. How about, so we did D. Oh, so there's one more, E. So let's look at E. So this one's kind of different looking, right? So notice E has this outer for loop that's very similar to what we've seen already. I starts off at 1, goes up by 1 every time. I is less than or equal to 9, so it goes through 9 times, right? Probably. But then inside of here, we have 3 different inner for loops. That's something we haven't seen before. But each one is independent of the others, right? So it's not like this one isn't nested inside of this one, inside of this one, inside of whatever, So you do the first inner for loop, and then when that one's finished, you go to the second inner for loop, and so forth. So it's not, hopefully it's not too bad. So what does it do? So let's kind of keep track of I and J in our output. And you've probably noticed that you start seeing a pattern, hopefully, on most of these. So I starts off at 1, right? 1 is less than 9, so yes, we go in. So what does the first for loop do? So j starts off at 1. And then the test is, while j is less than or equal to 9 minus I. So 9 minus 1 is 8, right? So this first inner for loop is going to go through 8 times. And what does it do? Every time it goes through, it outputs a space. Right? That's all it does. So on this first line, we're going to get 8 spaces. 1, 2, 3, 4, 5, 6, 7, 8. All right.
How do we notate that on our paper?
you could draw like a underscore or something. That's what I would usually do if I did it up on the board. So I'll just do it here. Well, but then they end up looking the same, right? Anyway, so yeah, just draw like a little dash or something. 7, 8. And so what is, and the values of I will be going up, right? They'll be going like that. And it'll be false when it's 9, right? So what does that second loop, inner for loop, do? Well, we just saw that one in part C. J is equal to 1, J is less than or equal to I, J plus plus. That was that triangle thing that we had kind of going on, where whatever row it was on, it would go through that many numbers, right? And here they have in a field width of 1, which is kind of silly, but anyway, output J. So again, J is starting off at 1. So it's going to output 1, right? And then J becomes 2. 2 is less than or equal to 1 is false. That's right here. And so we're done with the second inner loop. So what is this third inner loop doing? Notice it's counting down, right? J is going to start off at 1 minus 1. And it's going to go down by 1. It's counting down. And the test is, as long as J is greater than or equal to 1. Well, 0 this time, 0 is greater than or equal to 1 is false. Right? So this time it's not going to do this third loop at all. So we're done with that pass through the outer loop. So then we just go down to the next line. So that's 1 pass through the outer loop. The next time through the outer loop, I is 2. 2 is still less than 9. So we're going to go inside. What does the first inner loop do this time? So it's counting up, right? It's going to give us a certain number of spaces. 9 minus 2 is 7. So we're going to get 7 spaces on this second line. 1, 2, 3, 4. I lost count. 1, 2, 3, 4, 5, 6, 7. Okay, there's your first inner for loop. And again, the values of J will be going up. I don't think I necessarily need to show that there. How about the second loop? So again, on that second loop, I starts off at 1. And again, we were here. So it's going to output 1 and 2, right? Because the values of J will be 1 and 2. And then when J becomes 3, the loop will be false. Right? The second loop, 3 is less than or equal to 2. All right, so what about the third loop? J starts off at 2 minus 1, which is 1. 1 is greater than or equal to 1 is true. So it goes inside the loop and outputs J, which is 1. And then goes down by 1. So 0. And 0 is greater than or equal to 1 is false. So that's it. So there's your second line. Everybody see the pattern yet? I becomes 3. 3 is less than or equal to 9 is true. So go inside the outer loop. How many spaces do we get this time? 9 minus 3 is 6, right? So you get 6 spaces. 1, 2, 3, 4, 5, 6. And the values of J will be going up. And then this time through the second loop, the values of j will be 1, 2, 3, and then it'll be false when it's 4. So what do you get there? You get this, right? 1, 2, 3. And then that third loop, I will start off at 3 minus 1, which is 2, and then count down, right? And I'll put j every time. Just like that. See what's going on there? The next time through there, I is 4, so you get 9 minus 4, 5 spaces. 1, 2, 3, 4, 5. And then that second loop, we'll start counting up. 1, 2, 3, 4. And that third loop, we'll start counting down. 3, 2, 1, like that. And then when I is 5, you'll get 4 spaces, right? 1, 2, 3, 4. And then the second loop starts counting up. 2, 3, 4, 5. And then the third loop starts counting down. 4, 3, 2, 1. Like that. On the human loop. And then when I is 6, you get 4 spaces. No, I'm sorry, 3 spaces, right? 9 minus 6 is 3. 1, 2, 3. And it starts counting up. 1, 2, 3, 4, 5, 6. And then it starts counting down. 5, 4, 3, 2, 1. So we're getting this tree thing. Right? When 7 is still less than or equal to 9. So you get 2 spaces. And it starts counting up. 1, 2, 3, 4, 5, 6, 7. Then it counts down. 6, 5, 4, 3, 1. Do this a couple more times. When it's 8, 9 minus 8 is 1. So we get 1 space. And then it starts counting up. And down. And then when I is 9, nine is equal to 9, right? J starts off at 1, but then it's like 9 minus 9 is 0. 1 is less than or equal to 0 is false, so that first inner loop won't go through at all. But then we hit the second one, it counts up. And then the third loop will go through 8 times, and it'll count down. Like that. And then I becomes 10. 10 is less than or equal to 9 is false. We exit out of the outer loop. So that's what you get. Does that make sense? So let's test it and see if we're right. I had modified this one on the field widths. I made them 3 instead of 1. They don't have a 1 on the first thing, but if y'all put a space in a field with a 1, it's going to be a space, right? So there you go. Make sense? All right, cool. So those are the main ones that I think that gives us a good variety of different questions that we've gone over. And so there'll be some questions kind of like that on the quiz. You know, what's the output of this code, and so forth. All right, questions. I'm going to stop this. I think I'm still going.